Hello guys. Okay, so I'm back with chapter 13. I have done a simple summary on the chapter, so I hope this can help you to understand a little bit clearer than your self-study session. Okay, so for chapter 13, it's related to heat and temperature. So for this chapter, there are, I think I've summarized to 5 parts. So let's start. So the first one is temperature scale. So for the temperature scale, normally you will see there are three temperature used. It's either degree Celsius, degree Fahrenheit, and also Kelvin. So please note that Kelvin is our SI unit. Okay, so since we have a lot of units, so you should know that there should be conversion need to be done if you are given in Celsius, degree, or Fahrenheit, since we will use more in Kelvin. Okay, so the conversion is like this. So you have from Celsius degree to Fahrenheit, or from Celsius degree to Kelvin. So please see it carefully. And then we have thermal expansion. So for the thermal expansion, it's where when the temperature is increased, so that means the atoms will vibrate with larger amplitude, and it will increase the separation between the atoms, so the solid will expand, or the substance will expand. So in a way, there are two types of expansion. We have linear expansion and also volume expansion. More or less, linear expansion is related to solid, where volume expansion related to either solid or liquid. So you can have the equation. So for our chapter, we will focus more on linear expansion. So it is expressed by this formula: delta L equals to L naught alpha delta T. Okay, where you have delta L is what you call as new length minus original length. So because it is already been expanded. And then we have LO, or L naught, equals to the original length. And then coefficient of thermal expansion is alpha. It's either in K -1 or per Kelvin or per Celsius. So this one I will explain more later. And then just note that for the coefficient of thermal expansion, it will be different for different material. Okay, and then we have temperature change in Kelvin or Celsius degree. So this is where I want to explain a little bit on the temperature change. It can be in Kelvin or degree Celsius. It's because, for example, you have initial temperature in Celsius degree is 5, final temperature is 7, temperature change is 2. So if you make a calculation in Kelvin, you will have this much of temperature, and then you also have 280.15 Kelvin. In a way, okay, temperature change in Kelvin is also 2. So it's actually the same. The next part is heat energy, and the meaning of heat is energy transferred from one body to another due to temperature difference. So heat move from higher temperature to lower temperature. So this is where you can also see when you make yourself a cup of coffee, and then you use a steel spoon. So you can see after some time you can feel the hotness to your hand, because it's already been transferred, okay, from a higher temperature to lower temperature. It is denoted as Q. The unit is joule. It is also known as thermal energy and internal energy. So there are two types of heat you can have. First, Q equals to mc theta. This is the equation. So this is the heat required to raise the temperature of certain mass of a substance, where C is the specific heat capacity, depends on the type of material. So it can be in J per kg per Celsius, or also you can have it in J per kg per Kelvin. Okay, next up is Q equals to ml. So this one is heat supplied or removed to change the phase of the mass of a substance without changing temperature. You will only use Q equals to ml when you deal with a phase change. Okay, so for the phase change is what you have from solid to liquid, or liquid to solid, from liquid to gas, or gas to liquid, or you can also have some substance that can be changed from solid to gas and gas to solid. Okay, so there are three types of latent heat. we have LF, LV, and LS. So LF is the latent heat of fusion, LV is the latent heat of vaporization, and LS is the latent heat of sublimation. So this will be given as constant normally, so you just need to know what type of phase change you are dealing with. Okay, next up is the fourth part is where you want to deal with the phase change from ice to steam. So let's take, we have the temperature from -10 to 120. So in this case, you need to know that ice will become water and then later will become steam. So for water, we have melting point at 0 and then boiling point at 100. So here is the graph. So you have from -10 to 0 to 100 and 120. So for the phase change, you actually have 5 heat change. Okay, so you will have to find out one by one. Okay, so see this carefully again. Okay, so for the total energy required, so the total energy is QT. Okay, this is total. Q1, Q2, Q3, Q4, Q5 is referring to each stages. So one by one, Q1 is the change from -10 degrees Celsius to 1. This is where the ice warms. And then we follow with MLF. This is where the change of phase from solid to liquid, where the water will the ice will melt to water. And then we have MC delta T from 0 to 100 degrees Celsius for the liquid warms up. And then we have MLV, phase change from liquid to gas, and it vaporized to steam. And then for the steams warms to 120, we use MC delta T again. So whenever you have change in temperature, we use MC delta T, and whenever we have phase change, then you use the latent heat. So be careful here, we have LF and also LV. And last but not least, we have calorimetry. So for the calorimetry, we have the conservation of energy. So conservation of energy says that heat lost by one part of the system equal to the heat gained by the other part of the system. So in a way, you can write it as Q loss plus Q gain must equals to 0 because it is conserved. So that means if you rearrange this one, you will get Q loss equals to negative Q gain. And then rearrange and expand, you will have it this way. Be careful, on the right side you will have negative sign. So again, do the expansion. So delta T means final temperature minus initial temperature on this side also, but because of this negative sign, you can change it. Now becomes MCTF minus Ti for the lost part on the left, and then it becomes MC T initial minus T final on the right because your negative sign is there. So that's all from me from chapter 13. Thank you.